Can you see my screen, Alessandro?
Yep.
Okay, a little bit of intro about GeoSolutions and what we're going to talk about. This is a, let's say, DevOps-oriented webinar, another one. It's going to be more of this. We already had one a month ago. You will find links in the slides if you weren't attending the recording as well as the slides. In this case, we're going to talk more about how to monitor, Matter, and troubleshoot GeoServer instances. Some fact about us. GeoSolutions is an Italian SME. It was founded around 15 years ago. It's been a while. And we have offices in Italy and US. We work with a number of open source products for which we are core developers. The most widely known one is GeoServer, which we are going to talk about in a bit, but also MapStore, which is an open source WebGIS framework that obviously works nicely with GeoServer to build the web applications. GeoNode, which is kind of an SDI in a box. It uses GeoServer and MapStore. GeoServer for the heavy lifting of the data, MapStore for visualization, and PostGIS for storing data. And GeoNetwork is a catalog service, which is what you need if you want to build Inspire compliant discovery services, or if you in general want to have a discovery component in your infrastructure. Being an open source company, we do not sell licenses. What we do sell is our services one way or the other. So we do sell support services for the products above. So if you need professional help and professional support for consultancy, customizations, priority bug fixing, and so on, we do it for all these products. We do sell deployment subscriptions, which means we take care of your deployments, we certify it, and we keep it monitored. We perform checks on it. If there is bug fixes that we have to do, we do it all for a single fee. So it's slightly different than support services if you wish. It's more like a fee-based service. We do develop customized solutions, vertical solutions, mixing the products above, and of course, training services. So far, we've had more than 200 clients from all over the world. Our reference market is Northern Europe and North America, as you can see. We work in many industries. We started in defense. We were actually working for a NATO center in Italy, and from there we extended to many other different fields because GIS, which is what we do, is horizontal to many different fields. We are obviously part of OSGeo, and we strongly support it. We are OGC members. We work a lot with OGC because we are strongly supporter of OGC standards and interoperability in general. And our US subsidiary is member of USGIF for the US. A little bit more information about us. We are around 30 people. Most of us are software engineers, so we are a very horizontal company, technical oriented. Here you can see some of the core people at GeoSolutions. For the different products, we have at least a core committer on any of the products I mentioned before. Actually, we have, for most of them, more than one. For example, for GeoServer, we can say that we are the lead developers. Since we're here, we are hiring. So if you like open source, if you have experience with one of the tools and you want to work in an international environment with challenging tasks, send us your resume. There are links inside the slide. I see a question. This is not a free consultancy webinar. So we'll try to answer questions, but they need to be related to the webinar. So if you have this kind of questions, you can go to the mailing list or you can hire someone to help. Okay, I'll do a little bit of the intro, Alessandro, then I'll hand it over to you, okay?
Okay.
So what is GeoServer? This might be, let's say, not that useful for everybody, but I mean, we can't assume everybody knows everything. So a little bit of introduction is useful also for those who will be looking at the recording afterwards. GeoServer is actually an enterprise application written in Java using enterprise technologies, whatever that means. Basically, it means Spring and other technologies. Simply put, you can take your geospatial data, shapefiles, geotiffs, PostGIS, Oracle, etc. Configure GeoServer to serve it, and then you can access it using a number of OGC standards as well as de facto standards. So you can create maps by styling your data and accessing them through WMS or WNTS. You can access vector data via WFS. You can access raster data via WCS. You can pre-process and you can process your data using WPS, and so on and so on. Putting everything into a picture, this is what GeoServer looks like. On the left, you have all the input formats. Some are part of the core GeoServer, some are free and open source extension that you can download and install from the web. In the middle, you have GeoServers. Some of these protocols are core modules. Some are free and open source extensions that you can download and install from the web. And on the right, you have the output format. Same thing. Some are part of the core GeoServer, some are not. What you download from the web at GeoServer is what we think is actually the core GeoServer, but GeoServer is modular. So you can add more elements, you can extend it, and so on and so on. Okay, Alessandro, over to you.
Thanks, Simone. I'm going to share my screen now. Okay, you should be seeing my screen. All right, let's start from the beginning. Let's start with some terminology about what we're going to discuss today. So the webinar is about logging and metering. So let's discuss about what is logging. Generally speaking, logging is refers to the ability to collect, aggregate, and parse logging events across the entire infrastructure. And there are different kind of logs that you can collect, parse, and enrich. There are application logs, for instance, GeoServer logs, PostgreSQL logs, and generally speaking, application level logs, and infrastructure logs. So this refers to things like sys logs, access logs, and so on. So anything that is related to the infrastructure. Then we have metering. Metering is about collecting index and measurements of performance of the infrastructure and the health of the infrastructure. So we're talking about hardware metrics or software metrics. Could be hardware metrics, for instance, could be CPU usage, memory usage, disk usage, and so on. Examples of software metrics would be response time, throughput, error rates, and so on. There is also the concept of instrumentation, which refers to artificially adding bits of codes basically to your application to get more insights about the performance of the application itself. This is can have an impact on the infrastructure and the performance of the application, so it's not as common as hardware and software metrics. Besides from logging and metering, we also have alerting, which refers to the ability of receiving alerts based on specific conditions that are met by your system. This could be something bad or something good, and there are actions associated with it usually. So notifications could be Slack messages, could be email, could be paging the system administrator, and so on. And there's also an active element, which could be human intervention or some sort of automated tool that takes care of fixing the infrastructure for you. Alerting, of course, is built on top of metrics because alerts are triggered by metrics. So monitoring, generally speaking, is a combination of all the things that we just introduced. So metering, logging, alerting, they all together work towards implementing monitoring of your system or infrastructure. So observability is important. So it's important to have an eye on the system from the outside. So looking at the system from the point of view or of an external user, but also from the inside. So we also want some logs and information from the application themselves as they are performing tasks. For this, microservices can help, of course. By using microservices, you're kind of isolating bits of the tasks that are going on that are performed by the application. So it can be easier to identify issues with specific parts of the infrastructure. Keep in mind that monitoring can have an impact of the infrastructure on the infrastructure and the services. So you should set it up carefully so that it's lightweight and it doesn't impact your system. One other thing to be aware of is the alert fatigue, which is what we refer to when we're receiving too many alerts or too many notifications for errors or false positives. And this, of course, is detrimental. When people get paged or receive alerts all the time, they tend to, of course, start ignoring these alerts, and that's bad. That's not what we want. A mix of good metrics and logs can help us finding issues with our systems and intervene in a timely manner. Here you can find some resources online if you want to check them out and get more in depth. There are plenty of resources available. These are some that I will listed for you. Okay, now that we've discussed some of the terminology, let's take a closer look to GeoServer. And we start with some basic concepts that are relevant for GeoServer administrators. They're not necessarily related with logging and monitoring of GeoServer, but are useful, generally speaking. We have already looked at some of these in previous webinars, but it's always good to refresh these concepts because they are quite important. So GeoServer data directory, what's the GeoServer data directory? It's a bit counterintuitive. It's not meant to store data. It's actually meant to store configuration of GeoServer. So it's a directory, actually a directory tree, containing all the configuration of your GeoServer instance. The GeoServer data directory is loaded in memory during the startup of GeoServer for performance reasons. So it's not checked continuously by GeoServer. If you make changes to the data directory, GeoServer will not know anything about it until you restart your GeoServer instance or you perform what's called reload of the configuration. Reload of the configuration that you can perform either via GUI. There's a nice button in the status page for it, or via the REST API. It's important to know that configuration reloading doesn't break OGC services. So if you're serving maps, the service is not going to be interrupted by a reload of the catalog, but it's blocking the GUI access and the REST API. So while GeoServer is reloading the configuration, you cannot access the administration page, and you cannot perform other REST operations against GeoServer. It's something to keep in mind, especially if you're if the reload of the catalog is taking a long time, or you're performing heavy operations in terms of configuration changes. So GeoServer internal configuration, which is also known as referred to as the catalog. I may use the two words interchangeably. It's not thread safe. It's meant to be to handle a high volume of parallel reads. So that's why it's not thread safe. There is no actual lock during this operation. But writes are serialized. So as we said, you cannot make concurrent changes to the configuration. OGC requests, on the other hand, of course, can go in parallel and should and must go in parallel. Operations like get map, get feature, all of the nice OGC operations that we use to access our data in GeoServer, they should go in parallel. For the reason I mentioned above, you should try to keep expensive operations outside of configuration changes. So configuration changes should be fast and do not impact the services. Here you can find some links about application tuning, configuration tuning for GeoServer, about how to set up your Java virtual machine properly, configure counterflow limits, resource limits, and so on. And now let's jump to false myths about GeoServer. So here are some of the false myths about GeoServer. The first one being GeoServer needs a lot of memory. This is actually not true. We deploy on a daily basis GeoServer instances with 2 to 4 gigabytes of heap and 4 CPU cores each, unless you have a big number of layers, which means more than 1 million typically. 4 gigabytes should be enough, unless you make very large PDF prints or PNG maps. Again, 4 gigabytes should be more than enough. If you have more than 4 CPU cores available, that's great. GeoServer can use them. If you don't have more than 8 CPU cores available, you don't need more than 4 gigabytes of RAM typically. So another false myth is GeoServer is slow. If you're not pre-processing correctly your data, if you're not careful about how you set up your GeoServer instance and you configure it, it can be slow. But generally speaking, GeoServer is definitely not slow, and we'll take a look at some examples in a second. You should pay attention to how you...
Alessandro, sorry, there is a question. Let me answer it. Okay.
Yeah.
So for the others, let us consider we added the main data outside the GeoServer data directory, but store only the data configuration of GeoServer data directory. In this case, how we can backup and restore easily? We do suggest to keep the data outside the data directory rather than inside the data directory. Why? Because you want to backup the configuration, which is actually as simple in most cases as zipping the data directory, versioning and put it in somewhere. that put in data into it, because at that point, especially if you start putting raster data, backups can become very big. And it's going to be super difficult to do differential backups. And then how do you backup PostGIS? It's going to be, or Oracle or anything, it's going to be outside anyway. Backupping data and backupping the configuration should be separate tasks and should be kept separate. So we always suggest to keep the data outside the data directory. This is also an impact when you do clustering. At that point, you will have to share the data. So you don't want to put the data inside the data directory, especially if you're talking about raster data or shape files or geo packages that might be in a shared storage anyway. Okay. Sorry, Alessandro.
Okay. Okay, thanks. Right, so you definitely should be paying attention on how you process and publish data in GeoServer and how you tune your configuration. We had previous webinars all about these topics that are available online and in our YouTube channel as well, if you want to take a look. So GeoServer is slow is a false myth. Here we can, here's a quick example. It's one of our GeoServer instances, which is serving OpenStreetMap data and Sentinel-2 process data. It's a raster background here. Here on the right, you can see some stats about this server. The average response time is 33 milliseconds. So definitely not slow. And maximum response time is still below 1 second. And this accounts for all requests, cached, non-cached, whatever. The load on the system currently is about 160,000 requests per day. And if you want to take a look at the data available, there's a link embedded in the slides that we'll make available after the webinar. Okay, some scenarios where you may end up with high reload times or high memory usage are listed here. So having a higher number of layers, you can slow down GeoServer startup, it can slow down GeoServer get capabilities documents, and so on. There are some ways, some workarounds for these scenarios, like partitioning with virtual services or workspaces. It's documented in the online documentation of GeoServer. Also, sharding on different instances is another option available to you. Sharding, very briefly, means having dedicated instances for a specific set of layers. So you may have a cluster where the configuration of all the GeoServers is not exactly the same, or you have a few layers published in one instance or the other, or you can actually implement sharding at a higher level, where you're at the load balancer level or the reverse proxy level, where you're directing some requests to specific instances. Okay, here you can find links to the previous webinars. If you want to know more about these topics, we covered all of them in the webinars listed here. There's also our training material, which is available for free online, and it's quite, it gets quite in depth about these topics. So back to the main topic of the webinar, logging, metering, and monitoring GeoServer. Sorry,
Alessandro, there are a couple of questions that I'll try to answer quickly, okay?
Yeah.
Bjorn, with CPUs, we mean CPU cores, okay? So if you have, actually with hyperthreading, if you have 6 codes with hyperthreading, that means 12 codes for us, okay? And then Gert, the previous slide mentioned something about the platform-independent binary. I'm not sure what you mean.
Yeah, probably the false myth about GeoServer being slow. If you're running, for instance, the platform-independent binary is not meant to be used in production. So
yeah, that's a good point. We do use the platform-independent binary here as there, but the goal of the platform-independent binary is to make tests. It uses an embedded version of GeoServer with an old version of Jetty. So in production, we never use Jetty. We tend to use Tomcat. I'm not saying you shouldn't be using Jetty, but you should be using the latest Jetty release with all the bells and whistles, not the one that we ship with the binary. The binary is just for quick testing and prototyping. We do suggest to use either a Docker image, a proper Docker image. We have one in our Docker hub. Soon there will be one for GeoServer when we find an agreement, or you can use Tomcat with the WAR file. Jean-Louis, best to store vector files in PostGIS or other DB or in files? That's actually not a question that we can answer simply. I'll try to. And I give a hint. At a certain point, you will see pointers to GeoServer in production slides. There are actually in that presentation, as well as in that webinar that we gave last year, indications on what to do when with the various formats and so on, okay? But simply put, when you have large data sets and you filter them, when you visualize them or you access them, it's best to use PostGIS with proper indexing. GeoPackage is usually pretty good as well. We use it for both vector and raster data, although I mean, you don't want to write having GeoServer in GeoPackage because it's a single file database. Okay, so it's not meant for be used that way. Shapefiles is usually decent again for reading. If you want to write, always use a proper relational database or MongoDB or something like that. Tech limitation on layers. I suggest you to go and look at the previous webinar because we discussed this, okay? The previous webinar as well as GeoServer in production webinar from last year. There are links in these slides as well. Lucas. Yeah, I mean, as I said, this is not a free consultancy webinar. I mean, this is not, let's say, a question related to the webinar or anything like that. And this is too specific. This is for you, Alessandro. Kubernetes login thoughts. I think we were going to touch it later, but you can say something probably.
Yeah, we're going to have a dedicated webinar for it. Maybe the only thing worth mentioning here is Kubernetes comes with some functionalities that allow you to easily centralize and collect all of the logs from your containers. So it's a good idea to leverage those. And but to get into, I'm not going to get into the details now.
So yeah, we're going to do other webinars like this, and one that we have in mind is actually containers, Docker, and Kubernetes, and anything else. I mean, Terraform, whatever. We try to come up with a blog post soon. We'll probably do this before the end of next month. Okay. Okay, go on, Alessandro.
All right. Okay, so now we get into the details of logging in GeoServer. So again, logging is about collecting and aggregating logs from various sources. When we're talking about application logs, specifically GeoServer logging, we want to look at GeoServer standard logs. So the regular GeoServer.log file that is generated by GeoServer. But that's not just that. We can also leverage some extensions and get more information with the monitoring extension and audit logs, which we're going to cover in a minute. And you can also collect access logs. These are usually made available by the application container, so Apache Tomcat typically. Metrics. So we want to look at things like response time and throughput to get an idea about the performance of our cluster. And we can aggregate this information on various levels, at the layer level, at the service level, and so on. We will take a look at this again in a moment. Other kind of metrics we want to look at is the uptime. Of course, we want to know if our services are up or down at all time. And as we said, we want to be paged about it if the services are going down. CPU and memory usage, you want to keep an eye on the CPU usage because GeoServer is CPU intensive. So it's normal to have CPU spikes. If you look at some graphs about CPU usage on your nodes, it's normal if you see spikes in the CPU usage. You don't want to run out of CPU, generally speaking, as a resource, because that would slow you down. And memory usage is, of course, something we want to keep an eye on, especially if for some reason you configure GeoServer with lots of heap and you don't have lots of RAM on your nodes. You may end up in a situation where you run out of RAM and the application is killed. Disk space usage, it's one of the first thing that comes to mind when we talk about metrics and monitoring, but it's also one of the most common issues actually that we found on production systems where they run out of this space. And it's easy to prevent as well. Errors and exceptions rate, that's also important to look at. If you're thinking about looking for errors just by looking at access logs and HTTP status codes, that's not enough. By standard, by OGC standards, GeoServer usually logs exceptions in the response of your request. So even in a situation where you get an exception, you get back an HTTP 200 code, which means okay. So you may not realize there are exceptions being returned to the users when they actually are. So you want to take a closer look at that. Alerting, we want to be paged about out of memory errors, which can happen, of course, to any application, and the service being down. Response time is something you may want to be paged about it as well as error rate. Okay, let's take a closer look at the logs, and we're specifically looking at the application container logs. Here we're looking for instance, at Tomcat logs. You may be using a different application container, but this is by far the most common one. So we picked that one for our example. Apache Tomcat, by default, is going to create the following logs for you. You have a catalina.out log where application lifecycle messages are being written. So things like application startup, application stop, and so on. If your application is not coming up, this is one of the places you want to take a look at to debug startup issues. localhost.log is host-related information. In some cases, you may find initialization errors in here as well. Typical situation is a misconfiguration or a corrupted data there. You typically find some errors in here. Then there is manager logs. So by default, Apache Tomcat comes with an example application, which is the Tomcat Manager application that allows you to deploy and reload applications at runtime. If you have the application deployed, that's where it's going to log information for you. And finally, access logs, the one we were mentioning before, where all the incoming requests are logged, one per line with a timestamp and HTTP status code. Then we have application logs. And this is the typical example of a GeoServer.log file, where the application itself is logging information. You will find in here information from GeoServer and its internal components as well, like GeoTools and GeoWebCache. It can be quite verbose. It's something I'll keep on coming back during the webinar, because it's something to pay attention to for performance reasons and also to avoid filling up the disks of your servers. So log profiles, there are a few defined in the GeoServer data dir, in the default GeoServer data dir. You should pay attention to the log level configured in GeoServer. For production systems, you should be using either production or quiet logging profiles. The other ones are definitely too verbose for generic use. You may want to consider using the others for debugging purposes. By default, GeoServer is behaving nicely and is rotating these files for you every time you restart your GeoServer instance or at a given threshold of log lines. We can see an example here on the right, which I think is the verbose profile defined in GeoServer, where everything is logged at a trace level or debug level. And you can also see the rotation configuration of these files. So how many files are kept, how many log files are kept for reference, for instance. Log files location. If you're running a cluster of GeoServer, you definitely want to customize this, because otherwise you run the risk of having many GeoServer instances trying to write to the same file, which is a problem. But you should consider changing the path of these files, so externalizing the path of these files in all scenarios. So even if you're not running a cluster, it's always a good idea to move these files out of the data directory to avoid bloating your data directory for reasons we've touched in the previous webinar, like making it easier to take backups of the data directory or move the data directory between environments. It's a good idea to keep it lean and clean. So put the log files out of the data directory. There's a link to the GeoServer documentation where you can find how to do it. Also, another reason to do it is to choose a location which is reasonably fast in terms of write access by GeoServer, because as we said, it's quite verbose and we don't want to be waiting on IO, blocking on IO, waiting to write statements to the log files. So that's another reason you may want to consider overriding the location of the log file. Logging levels. By default, GeoServer is going to log in 2 places. So the application log that we were mentioning before, the geoserver.log file, as well as to standard out. The web application logging to standard out will result in the catalina.out file being written. So you will end up with the duplication of all the log statements in the 2 files, which is generally speaking undesirable, and for performance reasons as well as disk usage, so storage usage reasons. There are several log levels, as we mentioned before. For production environments, use either quiet or production. GeoTools developer, we usually use this when we're trying to debug problems at the data access level. So maybe database access, the database is not reachable by GeoServer, or file system is not writable, files are corrupted, unavailable, these kind of things. And verbose level is the last resort, is extremely verbose. It can easily write down hundreds of lines per each request. But of course, you may have to use it if you're trying to debug some problems with your GeoServer. Keep in mind there's a performance hit associated with logging. So logging exceptions especially can be quite time consuming. So as we said multiple times already, keep your log level low if you don't need it. Now let's take a look at another kind of logging, which is audit logging in GeoServer. So thanks to the monitoring extension in GeoServer, there's a link in the slides. You can have more fine-grained information about the requests served by GeoServer. The extension can be easily installed like any other GeoServer extensions by dropping the jar files in the webinflip directory of the web application. And it's going to track the requests made against the GeoServer instance by the end users. This information can be stored in multiple places in memory, on disk, or in a database. We typically store it on disk, or generally speaking on some sort of file storage. And it can be configured. It's quite flexible on how you configure it. You can configure it, for instance, to log files in CSV formats, like the one that we're looking at. And here's an example of a request being logged to the audit file. This is actually coming from the maps server that I was mentioning before for the Sentinel-2 and OSM layers. We can look at the information that's available in the audit file. We have the type of service being requested. This is a WMS request, the version number, so WMS 111. The operation is getMap, layer name, workspace and layer name. The bounding box, the URL base path, as well as the full query string of the request, which is quite useful when you're trying to debug some problems with failing requests. You can actually take this and replay it and try to reproduce the issue. The kind of operation, this is get. the start time, end time, IP address of the requester. This was an anonymous user, so it was not logged in to GeoServer, and the user agent. Finally, image format. This was a JPEG request. Cache related information. So this was a cache miss. And if there had been any errors, you will find here some information about the error. So this request was fine. We didn't run into any issues or errors. So this is set to false. If an error was triggered, then you will get the error message here at the very end of the CSV file. Okay, let's take a look at metering now. So how would you measure the performance and uptime of your services when it comes to GeoServer? There are many tools and services available out there for uptime. There are paid ones, free ones, on-premise ones, whatever. The one we like is called Geohealthcheck, which is an open source application which is specialized in quality of service checking for OGC services. So it understands WMS, WFS, OGC services in general, and is measuring the performance of the service of your services. So it's not a generic request. It can actually understand your get capabilities, document, and make requests against your layers and so on. It's quite easy to set up, and it doesn't come with big hardware requirements, so it's quite cheap to run as well. This is a kind of an example of external metering of the application. So we're looking at the GeoServer service or cluster from the outside, not from the inside of the infrastructure. Then with GeoServer audit files that I was explaining in the previous slides, we can have some information coming directly from GeoServer from within the infrastructure. This is quite different. The kind of information that you get is different. It's more fine-grained. It's more fine-grained, so you have information about response time and so on. And it's kind of a passive metering. So we're not prompting the service and looking at the response. We're actually looking at the service as it's serving requests to the end users. You don't get uptime information with GeoServer audits, of course, because audit files are generated by GeoServer. If GeoServer is broken or down, it's not going to log in the audit files. That's it. In terms of hardware requirements, it's higher, not the monitoring extension and the audit files. That's quite lightweight. It doesn't add any significant overhead to the services. But if you want to aggregate the audit files, as we will see in a moment, using an elk stack, for instance, then you have to set up the whole service stack, and that comes with higher requirements than Geohealthcheck, for instance. If you're interested in setting up the elk stack to aggregate these audit files, there's a link in the slides that you can check out. So logs shipping. We said we want to centralize logs. So we want to have all the logs available at hand in a single location. That's useful for troubleshooting issues in a timely manner without having to log into machines or whatever and checking the logs one by one. That's time consuming, and it's we won't be able to respond quick to any problems that may arise. One other nice feature to have is a search capability. Of course, we want to be able to filter out all these log events and search through them, because typically there's a lot of noise then we're not interested in look at. So it's a lot of information to look at. Search capability allows you to filter out all of this noise and makes it easier to find what you need. Again, for centralizing logs, you can set up your own service or rely on third parties. There are many available online. We will be looking at setting up our own system with the Jstack. Analyze logs, it was what was I was referring to a moment ago. So filter out all the noise and then enrich the logs. So as you ship your log files from the application from the nodes to the centralized location, shippers can add some metadata to it or enrich it. That's how it's said. And this kind of metadata or extra information can be useful for again for filtering out the noise and look at the information that you need. Things like operating system version or name of the machine where the application is running, or IP address of the server where the application is running, and so on. Okay, analytics. Here we look at how to implement analytics for GeoServer using the Jstack. So the Elasticstack is comprised of a few services: Elasticsearch, Logstash, Kibana, and generally speaking, Bits. Each one covers one of the areas that we're talking about. So Elasticsearch is basically where you centralize all your logs. It's a search engine. That's where you ingest all the log events or audit events to have them available later on, to be viewable later on. Logstash is the ingest pipeline. So it's used to ship logs to Elasticsearch, as well as parsing the logs and enriching the logs. And we will look at an example of this in a moment. Kibana is the visual part of the stack. Kibana is a web application where you can create charts, visualizations, dashboards, and so on, based on the data that you have ingested in Elasticsearch. And finally, Bits is what you're using for log shipping. There are several components to the Bits family in the Elasticstack. The one we're most interested in is called FileBit, and it's used to ship log files, basically, to, in this case, to Logstash. Okay. Now let's take a look at, in this case, we're looking at Kibana. This is an example of a dashboard implemented using Kibana, specific for GeoServer. And this is the kind of information that you can get from it. On the left hand, we have response time, average and max, number of requests, slow layers. I know it's not so easy to read now, but we will have close-up looks in a moment. Slow layers, frequently accessed layers, IP addresses of the requester, as well as geo-IP information, throughput, error rate, and so on. Using Kibana and the GeoServer dashboard, you can filter out events based on error conditions, so whether the request succeeded or resulted in an error, event time, layer name, again, response time, IP of the requester, location, and so on. And as we were saying before, another information that's available in the audit files, so as a consequence is available for you in Kibana, is the query string of the request that you can use to replay the same request and try to reproduce errors in your cluster. Here's a close-up look one of the events ingested into Elasticsearch. Here we're looking at a get map, just an example of a get map against a layer that's not available in the cluster. And here we can see it's clearly marked as an error. You get the error message, you get the query string, and all the information is broken down. So the CSV files, the audit files, have been parsed by Logstash, ingested into Elasticsearch, and now we're looking at them from Kibana. And here's the full event. Another thing that you can do with the GeoServer dashboard is analyze the performance of your cluster in terms of response time, find slow layers, trying to understand the cache usage in your cluster. So whether or not you're leveraging the cluster, you get some statistics about cache hits and cache misses, for instance. Popular layers, so insights on what's popular in your system, what are the users actually looking at, what they're interested in. And bandwidth usage over time, that's another kind of metric available for you, and more. Here's a closer look at the visualizations we were looking at before. If you were missing some of the details, you can take a look. Here's the pie chart, for instance, for cache hits and cache misses here in the bottom left side. Here we're looking at the most popular layers, in this case, GeoSolution states, response time, average and max. You can do more actually if you want. You can get you can get percentiles for response times. You can do a lot more with this kind of visualizations. And again, GeoIP, throughput, IP addresses of the requesters. Here, these are just closer looks at the visualizations. Okay, now we want to take a look at troubleshooting GeoServer. We're gonna go through typical scenarios where you have problems with your cluster. So the most typical errors and how to debug them and fix them. So despite all the efforts, bad things will happen. So despite all the effort that you put in, all the preparation work, the data processing, the configuration tuning, stress testing, and so on, you need to be prepared to troubleshoot your cluster. So you want to make sure you have your JDK tools installed, Jstack and Jmap. You want to make sure you have quick access to application, container, and GeoServer logs. You want to make sure you're able to raise temporarily the log level of GeoServer to get more information about what's going on. And it's advisable to have a test environment, of course, to try to reproduce the issues without impacting the end users. You should also make sure that you can scale down your cluster easily if necessary. It's a lot easier to debug problems when you're looking at just one GeoServer instance instead of a cluster of GeoServers. You can, for instance, get direct access to the administration UI, review the configuration, make quick adjustments to the configuration, change log levels, isolate the node, for instance, where GeoServer is running, and so on. So it makes your life easier. So make sure you're able to do it if necessary. Inspecting the logs is the first thing we do when there's a problem with a GeoServer instance. From the GeoServer UI, you will find GeoServer logs configuration in the global section of the configuration, and a dedicated section for the logs in the at the very top of the left-hand panel. Application container logs is the next step. So if your application, for instance, is not running or is down, or you don't find the relevant information in the application logs, then you want to look at the application container logs. You will find information like application lifecycle info. So for instance, GeoServer was stopped or started, out of memory errors, startup issues, and so on. And here we have an example, a typical example of an out of memory error due to heap exhaustion on the left, and a generic error on the right. So to troubleshoot startup issues, check the application logs. First file to look at is Catalina out, then localhost.out or localhost.log, depending on your system setup. You want to understand whether Tomcat itself started or not, because the issue may not be related with GeoServer specifically, but it could be something at the application container level. Maybe some permission issues, maybe the service is not configured correctly, and so on. Then you want to check GeoServer logs. So that can be helpful for debugging catalog loading issues, for instance. So if the configuration was broken or there were some troubles with layers configurations, styles configuration, and so on, you will find that information in the GeoServer logs. Or to debug long startup times, you can actually trace the startup process of GeoServer in the GeoServer log and trying to pinpoint or look at how long it's taking for each phase of the startup. And again, if there's some problem with the data directory itself, you will find it logged in the GeoServer logs. Another typical example is connectivity issues, maybe with database access. So GeoServer is not able to access PostgreSQL, for instance, for maybe networking issues or credentials issues, and so on. So what you want to do is try to access first, of course, make sure the service is the remote service is up and running. Then try to access it using the same credentials that GeoServer is using. If that succeeds, then you want to manually try to connect to the DBMS from the same machine or from inside the container where GeoServer is running, using a tool like Telnet or the DBMS client like PSQL, for instance, just to test that everything is working as it should. Another example would be a network or shared storage problem where GeoServer is not able to read or write data to some of the directories. You can try to access the storage yourself from the GeoServer machine using the same user that GeoServer is started with, typically Tomcat. And you can check, again, the GeoServer logs. GeoServer will typically log information about files or directories being readable or writable. Finally, another typical problem if you're using cascade services, so WMS Cascade or WFS Cascade, for instance, is the remote service is unreliable or slow. Okay, so that's another typical problem, and that's a problem because a cascade service that's unreliable or slow makes your GeoServer unreliable or slow to the eyes of your clients. Okay. Other sources of troubles: disk space, quite easy to check on Linux machines using the DH tool. Memory issues, again, we're making the example of Linux machines, but because that's by far the most common and recommended operating system to run GeoServer. You can use the free tool to check the amount of memory available in the system at any point in time. Or if you're looking for signs of memory exhaustion, which is not the same thing as an out of memory error. Here we're talking about the machine itself running out of RAM. You can use the dmessage command or look at the system level logs. And when the machine runs out of memory, the scheduler typically kills GeoServer first before any other application, because it's if you're only running GeoServer on that machine, that's likely the application that is using the most amount of RAM, and it typically gets killed. CPU usage, of course, you have your monitoring in place, but you can also use from the machine itself. You can use top or htop, and also keep an eye on the inodes. Especially if you're leveraging caching in GeoServer. Inodes are a finite resources in a finite resource in file systems. So when you create a file system, there is a maximum amount of files that you can store in it, and the number of files is configurable, but the default value is okay for generic use. When you're using the cache heavily, you tend to have lots of very small files, and you can run this strange situation where you have storage space available in your file system, but you cannot create any more files because you're out of inodes. And you can check this with df-i on Linux machines. It's recommended that you actually create a dedicated partition for caches if you're storing your cache tiles on disk, and you tune the number of inodes in your file system when you create it, because you cannot increase it later on at runtime. So it's recommended that you configure it properly once and for all. Here we have a couple of examples of Jstack and Jmap usage. So with Jstack, we can look at what GeoServer is doing. So we have a trace of the state of each thread in GeoServer, whether they in a block state, whether they're running or whatever, and where they're blocked or running. So the actual function they're executing. This is quite useful, for instance, if your GeoServer is stuck or appears to be stuck, you can take a Jstack and try to understand what it's doing. Maybe it's blocked on IO. Maybe you will find that it's blocked on getting connections from a connection pool to the database and so on. And finally, Jmap. Jmap can be used to dump the entire virtual memory of the Java virtual machine for later analysis. So there are tools like several tools available that allow you to analyze the memory space of the Java virtual machine, and you can try to understand what's allocating memory. You want to use this, for instance, if you're running out of memory. So if you have an out of memory error in your logs, before restarting your instance, you should take a memory dump for later analysis. A developer will be able to analyze that for you. Other resources, there's the official documentation for GeoServer. It has a troubleshooting section in it, so you can take a look at that. Common mistakes. Again, we briefly mentioned it at the beginning of the webinar. Maybe you're using the platform independent binary in production. That's not recommended. You should use the GeoServer war file deployed in an application server like Apache Tomcats. Not enough hardware resources. If your GeoServer is low and you're running it on a single core or 2-core machine, that's of course not enough. These days shouldn't be a problem to allocate more resources to your instances. Data is not optimized. We covered it in a previous webinars. You can have a look at those on how to pre-process correctly and publish correctly your data. And you can do the same at the styling level. For instance, that's covering the other webinars as well. GeoServer is not optimized. Make sure your Java ops are set correctly. Yeah. Too many layers. By too many layers, we mean like thousands or millions of layers. You can use parametric SQL views or sharding or image mosaics to reduce the number of layers. The lack of a test or QA environment is quite important to have it to troubleshoot things, as we mentioned. Monitoring, metering of logging. By now, you should know that that's important to set it up correctly and have it handy when needed. And you should be using caching when possible in GeoServer. So tile caching using GeoWeb cache. Another typical mistake is choosing the wrong type of instances. So if you're renting your machines from a cloud provider like AWS, Google Cloud, or Azure, whatever, you can typically choose the type of instance, and it can be one for general use. It can be a CPU optimized one. It can be a memory optimized one. People tend to think that they need a memory optimized instance, but that's not the case. You should usually pick the one with the faster CPU and more CPU cores. GeoServer likes CPU cores. Logging again, tweak your log level, unsupported JDK version. Maybe you're trying to run GeoServer with a version that is not supported. The list of supported versions is in the documentation. Corrupted or non-readable data dir. That's another typical source of issues, or generally speaking, machine level issues. So not enough disk space, RAM, and so on. But this should be all monitored, as you know. So you will realize in advance. Finally, a real-world use case. This is a full example of a system set up for monitoring purposes. So the whole monitoring from logging to metering to analytics, alerts, and so on. In this example, we're using a combination of the Jstack, Prometheus, Grafana, and some alerting tools. You can see on the left-hand side all of the applications and systems and machines that we're monitoring. We're retrieving information from these systems using either the beats from the Jstack or various exporters for Prometheus, or we're actually scraping the information directly from Prometheus. We're ingesting these events in the Elasticsearch, and we're looking at them either using Kibana or Grafana, depending on what we're looking at. Typically, Kibana for analytics purposes, for drill down, actually analyze the requests, and Grafana, we usually use it in combination of Prometheus to look at metrics. On top of this, we have an alerting level, which can be coming from either the Jstack or Prometheus, and it may end up in a DevOps or a system administrator being paged over PagerDuty. We're also having, of course, here at the bottom, the Geohealthcheck that I mentioned previously in the webinar, that is checking the uptime and quality of service of the various OGC services. Okay, conclusions. Let's wrap up the webinar. You should set up proper monitoring. It's crucial for production environments. So keep it in mind and plan it carefully for your next deployment, or try to integrate it in your existing deployment. There are many tools and technologies available. GeoServer comes with a few, like the GeoServer monitor extension to create audit files. It's highly recommended that you look at the monitoring extension and how audit files can be produced by GeoServer and how to aggregate those. And you should set up alerts to find out when something is not working as expected before your clients do. If you want to set up an Jstack and specifically dashboards for GeoServer, like the ones that I was showing you before, there is a link in the slides, which I can actually maybe paste it in the chat as well, to a GitHub repository where we put instructions and configuration files for Kibana. I'm going to put it in the chat right now. Okay, so question time. Okay, I have a question for Vadim. I hope I'm not butchering your name. How can I be sure that the old jar files in the weblib directory are suitable for new GeoServer WAR file? They are not. So each GeoServer version comes with its own WAR file, and the jars contained in it are changing from version to version. So you cannot just mix and match those. You should always re-download the extensions for your specific GeoServer version. I hope I've answered your question. Does GeoServer have Prometheus monitoring endpoint? No, not at this point in time. Is it planned? Not that I'm aware of. It would definitely be nice to have it though, to do some scraping directly from Prometheus to GeoServer, but I'm not aware of any of that at the moment. Okay. Any more questions? Are you using log4j JSON layout for ELK? No, we're actually not.
Alessandro, when you answer, you should click on, yeah, right.
All right, sorry. So Bjorn, we're not. We are actually shipping the log files using FileBit to Logstash. So we're not actually shipping the log files or audit files directly from GeoServer. We're relying on an external shipper like FileBit or Logstash itself.
I'll answer the other one. Joe, when using GeoServer to display millions of points from PostGIS, would you split it on two servers or rather use a real big CPU and lots of mem? Well, memory is not going to be an issue. CPU is going to be. We, I believe, touched this in the other meeting, but in the other webinar, but let me touch this again. If you expect GeoServer to be able to show millions of points from a database quickly, especially from PostGIS, well, I wouldn't say especially from PostGIS, like PostGIS, you're going to be in troubles. Why? Because I mean, you need to load millions of records and then render them on the fly. And this is not going to work. My best guess or my best suggestion is usually to actually not show this amount of data, but try to use exclusion rules and clustering based on the zoom levels. If you really want to show this amount of data, we actually do it in some cases. It's not going to be super fast. You want to use at that point tiling and multiple instances on GeoServer. You can scale out or you can scale up. The bottleneck here will be the CPU and the amount of time it takes to move all this data to GeoServer for the rendering. So for example, making the chunking from GeoServer to PostGIS larger will use a little bit more memory, but will make this faster. One way or the other, this is going to be a little bit slow. There isn't much you can do. What we usually try to do is, as I told you, using clustering, which means moving some of the work at the database level and moving less data to GeoServer, and or using exclusion rules in the SLDs and the styles so that you don't show too much data as you zoom out. Because again, I mean, if you had to show millions of points, it's going to be slow one way or the other. Anything else? Any other questions? Otherwise, we close the meeting. We went well beyond what we thought at the beginning. Okay, I think that's it. I'll close the meeting. I'll collect the recording as well as the slides, and I'll post everything in at the bottom of the blog post that announced this webinar, and you should receive an email with information. If you asked us to subscribe to our newsletter, you will get information about the next webinars. Okay. In any case, if you check our websites, we usually do a blog post like 3 to 4 weeks in advance. Thank you. Have a good day. Bye-bye.
Thank you all. Bye-bye.